Hello guys, welcome back to Pre-Cal. Right, we're going to dive right in on lesson 5.1, Trig Identities. Here's your warm-up, pause your video and come back to see if you've got them right. So going over this in 3, 2, 1. So in question 1, we want to solve the cosecant of x. So we want to end up with cosecant of x equals something. Okay? So let's have a look at what we've got here. All we have to do is we can cross multiply. So we have the cosecant of x times the sine of x equals 1. Now we just want cosecant of x, so let's cancel out this multiplication here. Cancel out this multiplication here. Get cosecant x on its own by just dividing both sides by the sine of x. And then that cancels that, and we are left with the cosecant of x simply equals 1 over the sine of x. And we should know that in any case, because they're reciprocals. Sine of x equals 1 over the cosecant of x, so you can kind of switch those around. Cosecant of x be 1 over sine of x. And doing a similar thing on this, we just want this. How would you get rid of sine squared x? Just subtract that from both sides. Okay? Right, here are your answers. This was a reciprocal. This one, we just wanted cot squared x. So we just subtracted 1 from both sides. This one was a big one. Lots of people get this wrong. Look at what you want. This is what we wanted. We wanted 1 minus cosecant squared of x. So we didn't want this cot squared x, so we had to subtract it from both sides. And that would leave us with 1 equals cosecant squared x minus cot squared x. But we didn't just want 1, we wanted 1 minus cosecant squared x. So, well, we had this 1 on its own then, we'd have to subtract this from it. We'd subtract it from both sides. So those will cancel. If you haven't got this minus here, you haven't done the algebra, you've just guessed. Okay, right, so what we're going to be doing in this unit, we're looking at something called trig identities. There's a big difference between an identity and just any old regular equation. We've got 3 types of identities that we start with. The reciprocal identities, and these are what we've just worked out. Sine of x equals 1 over cosecant of x. So that one's got its partner identity that the cosecant of x equals 1 over the sine of x. They're reciprocals of each other. Now these are identities and not just any old equation. An identity is true for all values of whatever your variable is. And in this case, our variable is this x. True, an identity is true for all x. You can't solve it and just get, oh, this is only true when the angle is 30 degrees or pi by 6 or something. It's true for any angle. The sine of the angle is the reciprocal of the cosecant of the angle. A regular equation is only true for some values of x, and you can solve it and find those values of x. Only true for some values of x. You can't solve an identity. You'd end up with something that says, well, 1 always equals 1, or something like that. Okay? So our other reciprocal identities, write these down, you need to memorize them. Cosecant of x is cosecant is the reciprocal of secant, so cosecant of x equals 1 over the secant of x, which also tells us that the secant of x is 1 over the cosine of x. Tangent of x is the reciprocal of cotangent, so this gives us another identity. The cotangent of x is 1 over the tangent of x. So we have 6 reciprocal identities. 1, 2, 3, 4, 5, 6. Okay. We have 2 quotient identities. You need to memorize these. A quotient, remember, is the answer. It's talking about division. Tangent of x is the ratio of sine of x over cosine of x. And because the cotangent of x is cotangent of x is the reciprocal of tangent of x. The cotangent of x is going to be the reciprocal of this. So cotangent of x is cos of x divided by sine of x. Now the Pythagorean identities, these are super important. I'm going to teach you a silly way that you're going to remember this one and this one very easily, but actually this one is the most important one, and you'll use that a lot when you get to calculus as well. Now, I haven't finished that off. There's something missing here. Let's go and have a look at this. Why they're called the Pythagorean identities, and we're actually going to derive them. So, what does the Pythagorean theorem tell us? It tells us that a squared plus b squared equals c squared. From a circle, if I had a circle centered on the origin, if I had any point on that circle and drew a little right triangle, then I know that this dimension is the x, this dimension is the y, this dimension is the r. And from Pythagorean theorem, we know that x squared plus y squared equals r squared. Okay, that's your basic equation of a circle with the center on the origin. From the unit circle, when the radius equals 1, what we know about that, if we have a circle of radius equals 1, oops. If I have a, oh, I don't know a circle, I'll read all that. Let's see. I'm really interested in what's going on in quadrant 1, but it's true anyway. If that radius equals 1, we know that the sine of this angle is equal to the opposite divided by the hypotenuse. When the radius equals 1, we know that the sine of an angle is y divided by r, so it's y divided by 1 equals y. So y equals the sine of theta. In a similar manner, the cosine of your angle is your adjacent divided by radius. Cos of theta equals the adjacent, which is your x divided by 1. So cos of theta simply equals x if this radius is 1. Yeah, if the radius is 1. So we know x equals the sine of theta. Put that into the equation we had, where we had x squared plus, oh, I've written sine there, I should have written cos, sorry. X squared plus y squared equals 1. We know x is the cos of theta, so we've got the cosine of theta all squared plus y equals the sine of theta, so y squared is the sine of theta squared equals 1. And we learned just before the break that the shorthand way of writing that is cosine of theta squared, you write cos squared theta plus sine squared theta equals 1. That's your primary, your main Pythagorean identity. Okay? It's written here as sine squared plus cos squared. Remember, when you're adding things, it doesn't matter what order you get them in. Now, there's 2 more of these. Let's go and have a look at, well, how we're going to derive them. Imagine you had this main identity, cos squared theta plus sine squared theta equals 1. And you divided everything by the cosine squared. Divide everything by that. What do we end up with? This gives us 1 plus, well, sine divided by cosine. That's one of your, oh, I don't know what it is. That's one of your quotient identities. Look and see what you wrote down just a few minutes ago. Sine theta divided by cos theta equals tangent of theta. So if you had the sine of theta squared divided by the cos of theta squared, it would equal the tangent of theta squared. So this sine squared theta divided by cos squared theta could be rewritten as tangent squared theta. And 1 over cos theta, we know that 1 over cos theta, that's the reciprocal of secant. So if you had 1 squared, which is the same as 1, over cos squared theta, that would be secant squared theta. So I can replace this term here with secant squared theta. That is our second Pythagorean identity. And to get our third Pythagorean identity, we're going to start the same thing. This time I'm going to write the sine squared one first. Sine squared theta plus cos squared theta equals 1. And this time I'm just going to divide everything by sine squared. Dividing everything in the whole equation by sine squared. Sine squared divided by sine squared gives me 1. Cosine divided by sine is cotangent. So cosine squared divided by sine squared is cotangent squared. And sine is the reciprocal of cosecant. So 1 over sine squared, that's like 1 squared. 1 and 1 squared are the same thing. That's like cosecant squared. That is our third Pythagorean identity. Okay? So here we have those two we just come up with. Now remember I said I was going to teach you a really silly way to remember them. It's very, very silly. And you're going to remember these. This is the most important one. This is the one you've got to remember. You'll need it forever. But these two, I've got silly ways of saying them. This is like, just say the expression, I tan in a second. You see, 1 for the I, tan squared, equals secant squared in a second. And this is my favorite one, the next one is very silly. I'm going to replace 1 with I again. I, cot sounds a bit like cut, and cosecant, I don't know, it just looks like cheesecake. I cut cheesecake. Now remember that gives you 1 plus cot squared x equals cosecant squared x. Now remember the angle would be x or theta. Now these are only true if you're using the Pythagorean. Everything here is squared, and remember 1 squared is the same as 1. The Pythagorean identities tell us that a squared plus b squared equals c squared. Not true. It is not true that a plus b equals c. Okay? These only work if you've got something squared, 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 squared. Ooh, and the bit that's missing from this first one, sine squared plus cos squared equals 1. Okay? So basically we've got 6 of these. I've only written out 3 of them that you have to memorize. 2 of these and 3 of these. You need to remember them all. Write them out nicely somewhere and refer back to them. Okay? Now we're actually going to use them. Simplify by writing in terms of sine and cosine. This is a technique. We have to simplify this so it just involves 1 trig function. There's 2 in there at the moment. And the simplest technique is to use your reciprocal and your quotient identities to get rid of everything that is not sine or cosine by replacing things by something they're equal to. Now, so when what this means, this first one, we've got the cotangent of theta, that's multiplication, multiplied by the sine of theta. And hopefully you've written down somewhere that the cotangent of theta, the identity, is equal to cos theta over sine theta. Okay, that's what you're thinking in the back of your head when you're doing this problem. That's what you're thinking. So when you see cot theta, you can replace it with something it's equal to. Cos theta times sine theta. That's that part. Then you've got the multiplication. Then you've got this factor here. Don't forget that. So these two lines are equal because I have replaced something here by something it's equal to. Okay, I'm not making this up. I'm not randomly writing stuff down. I'm only writing down stuff that's true. And now, can you see what we can do? This is because we're multiplying. You couldn't do that if this was only because this is multiplication here. If it's plus or minus, you couldn't do this. You can cancel out a factor in the numerator and a factor in the denominator, and we're left with the cosine of theta. Be very careful about what you cancel. You can only cancel factors, things that are being multiplied. You cannot, if this had been cos theta over sine theta plus sine theta, you absolutely cannot do that. Okay, that would be terrible. That's not multiplication. You can only cancel factors, not terms. Okay, right, so this next one. Well, it's given us a hint. We don't normally do this, but on the first day we do. We're giving you hints. So I'm going to replace everything by something in terms of sine and cosine. So I'm not going to change the numerator on this equation. I'm going to leave it as sine squared theta. And then I've got secant squared theta minus 1. Well, I could replace secant. I know that secant of theta is the reciprocal of cosine. So secant squared theta is 1 over cosine squared theta. There's actually, I'm seeing a very much easier way of doing this. Okay. There's a much easier way of doing this problem. Okay, so I'm going to have to combine those two fractions in the denominator over a common denominator by multiplying this by a carefully chosen form of 1. So what I've got in that denominator, I've got 1 minus cos squared theta over cos squared theta. Dividing fractions, you write up the numerator, and then instead of dividing, you multiply by the reciprocal. So I've got multiplied by cos squared theta over 1 minus cos squared theta. That's a much easier way of doing this. There really is. Ugh, you could have used the Pythagorean identity right at the very beginning here. You could have used I tan in a second. 1 plus tan squared theta equals secant squared theta. So you could have replaced this secant squared theta with 1 plus tan squared theta. It would be much easier. Oh God, I would finish this off and I'll go back and do it the way I want to do it. Okay. What I'm seeing here, I'm seeing sine squared theta. I know that sine squared theta plus cos squared theta equals 1. So if I subtract the cosine squared of theta from both sides, this side would be 1 minus the cosine squared of theta, and it would equal, when you cancel out that 0 pair, the sine squared of theta. So what I've got here is I've got the sine squared theta times cos squared theta divided by, I just said 1 minus cos squared theta is the same as sine squared theta. Is that actually one of the problems we did in the warm-up as well? Now, because we've got multiplication, we can cancel, and we're left with just cos squared theta. Now, as I said, this was a ridiculous way of doing that problem. Let's start that one from the beginning again. Ugh. Sometimes you go the long way around in a problem. I was just following the instructions. I don't normally do that, but I did for once. So let's start that problem again. We started off with sine squared theta over secant squared theta minus 1. Now, just using the Pythagorean identity, that 1 plus tan in a second. 1 plus tan squared theta equals secant squared theta. This is a little thought bubble in my head. So if I wanted secant squared theta minus 1, this, what I'd have to do is identities, subtract 1 from both sides. And what would I be left with? Tangent squared theta. So, carrying on, that was just a thought bubble. That's what I was thinking in my head. I don't need to actually show that in my work. So what I've actually got here is I've got the sine squared theta divided by, and this bit here, secant squared theta minus 1, is equal to, so can be replaced with tangent squared theta. Okay, now I'm going to rewrite that in terms of sine and cosine. Tangent squared theta could be rewritten as, using my quotient identity, this is what I'm thinking in my head. So tangent squared theta is sine squared theta over cos squared theta. Now just do your dividing with fractions. So what we do, we get the numerator, and where we've got this division, we turn it into multiplication, and we multiply by the reciprocal. And now, because we've got multiplication, we've got factors, cancel there and there. That was a much easier way of doing that problem. God. Sometimes you go the wrong way around. And I only do because I was following instructions. Let's try another one. See if you can try, have a go at these on your own. Pause the video and come back. Reduce. Okay, what am I seeing here? I'm not seeing anything squared, so I'm not going to use a Pythagorean identity. When I get to this one, I see that squared and I'm going to think, ooh, Pythagorean identity. Okay. On this one, nothing squared. So I'm going to just try rewriting everything. The easiest thing is think in terms of sine and cosine. So I know that the cotangent of theta is equal to cos theta divided by sine theta. And I've got multiplication here. There's nothing shown in multiplying. And I know that the secant of theta, that's the reciprocal of cosine theta. Okay, now it's obvious. Look what's happened here. I've got multiplication, so I can cancel a factor in the numerator by a factor in the denominator. That leaves me with 1 over the sine of theta. Do I stop there? Well, it said reduce. Kind of make it look, sometimes we write simplify. Could I simplify that further? Yeah, sure, of course I can. But 1 over sine theta, that is cosecant of theta, the reciprocals of each other. Okay, is that one? The lesson we do today is actually harder than what we're going to do later on in the week. Because on these ones, sometimes you don't know where to stop. Okay, this one. I'm seeing cosecant squared theta minus 1. So in my head, I'm thinking about my Pythagorean identities because I'm seeing this squared. And I'm thinking about, oh, I'm seeing cheesecake. And I know there's that identity that goes, I cut cheesecake. 1 plus cot theta equals cosecant theta. Is that right? No, not at all. It's only true if they're squared. 1 plus cot squared theta equals cosecant squared theta. So if I wanted cosecant squared theta minus 1, from this identity, I'd have to have this side and subtract 1 from it. So I'd have this side, and I have to subtract 1 from it. Cosecant squared theta minus 1 could be rewritten as it is equal to cotangent theta. Cotangent squared theta. Okay, thinking in your head, you know, if you had x squared divided by x, you've got x times x divided by x, what does it equal? Just x. This factor on the denominator cancels one of those on the numerator. Left with the cotangent of theta. And that's as simple as you get. Are there other ways you could write it? Sure. Another answer that we write would be this. But you ask yourself, which one is simpler? Definitely this one. Okay? The other answer is correct. This answer is correct. But this one is simplified. It's written in terms of just one trig function. Okay, so let's have a look at this one then. Try it on your own if you like, pause the video and come back. This I'm seeing squared, I'm thinking Pythagorean identities. This one, I know that 1 plus, I'm seeing the cheesecake one, 1 plus cotangent squared theta equals cosecant squared theta. So if I've got minus 1, I'd be taking off 1 from both sides, as we just did. That factor there can be replaced with cotangent squared theta. And yeah, I could replace sine squared theta using a Pythagorean identity, but now I'm looking at the fact that, oh, I've just brought in a cotangent. And so I'm going to leave that one for now. Because now if you've memorized your identities, this unit becomes easier, because when you look at things, you can just see what to do, because your brain's already thinking through the identities that you've memorized. Please memorize those identities, the ones I gave you at the beginning. So cotangent could be rewritten as cos over sine. But it wasn't just cotangent, it was cotangent squared. So we have to square those, of course you have to have an angle. And then we're multiplying that by sine squared. So can you see what's happening here? It's really obvious. We've got multiplication, because we've got multiplication, that's cancelled. We're left with cos squared theta. Now, this is showing us when we would actually use this. When you get into calculus, you had something really complicated like that, and you wanted to work out minimums and maximums on the graph or something like that. You use a process called differentiation. This would be really difficult to differentiate, whereas this would be very easy to differentiate. That's what you use these for. Okay, not teaching you calculus now. Okay, to simplify, can you see we've got two totally separate fractions? What we could do is combine them to just get one mega fraction by combining them over a common denominator. So to combine them over a common denominator, I'm going to get these two denominators and multiply them together. Secant theta minus tangent of theta multiplied by secant theta plus tangent of theta. Can you see what we've got there? We've got difference of squares. I haven't even looked at the numerator yet. I'll have to go back and fill that in. But think about what difference of squares is going to give us. A minus b times a plus b gives us a squared minus b squared. This is going to be, in the denominator, secant squared theta minus tangent squared theta. Okay? But what about these numerators? So this fraction here, this denominator had to be multiplied by this denominator. So this was multiplied by secant theta plus tangent theta, which means we have to multiply the numerator by secant theta plus tangent theta. So this one's numerator is secant theta plus tan theta, just multiplied by 1. Yeah, it's not going to change it. Then we have this plus sign. And then this second fraction, to get that common denominator, this denominator here had to be multiplied by this denominator. And if we multiply the denominator, if we multiply the denominator by the secant of theta minus the tangent of theta, you have to multiply the numerator by the same thing. Otherwise, we've changed it. The only thing you can multiply by is a carefully chosen form of 1. And that's what we've done here. These two blue factors make a 1, carefully chosen form of 1. Okay, let's just simplify what we've got now then. So the denominator we noticed was difference of squares, so we've simplified the denominator. That's just what I'm thinking in my head. Simplify the denominator. Let's look at the numerator. I've got secant of theta plus another secant of theta. So I've got 2 secants of theta. Then I've got plus tan theta minus tan theta. Oh, they're a 0 pair. They cancel each other out. Okay. Now what can I do? In the denominator there, I'm seeing squared things. That's making me think of one of my Pythagorean identities. What's my Pythagorean identity that I remember that's got secant and tangent in it? It's I tan in a second. Please don't go around saying that like it's something meaningful. This is just our silly way of remembering it. That tells me that 1 plus tangent squared theta equals secant squared theta. So if I subtracted tangent squared theta from both sides, then I would have, on the left, I'd have 1. On the other side, I'd have the secant squared of theta minus the tangent squared of theta. Okay? So in this fraction here, in the denominator, that equals 1, so it can be replaced by 1. So I've got 2 secant of theta can be divided by 1, which is just 2 secant theta. Okay, carrying on. Again, if you want to try them on your own, pause the video and give it a go. So again, can you see we've got 2 separate fractions, one fraction here minus one fraction here. You may not, this is not multiplication here. If this was multiplication, you could simplify factors, but it's not multiplication. These are separate terms. You cannot cancel out when you're adding or subtracting. You can only cancel out when you're multiplying. So what I'm going to do here is I'm going to actually combine them over a common denominator again. So in the denominator, I'm going to have cotangent of x multiplied by 1 plus the cosecant of x. And this fraction here is being multiplied by cotangent of x. So this numerator here must be multiplied by the cotangent of x. And this one here is being multiplied by all of this stuff. Can't fit it in there. So this must be multiplied by 1 plus cosecant of x. That's what's going in there. So I've got 1 plus cosecant of x times cosecant of x. Distribute. I can't write properly. Cosecant of x, 1 times cosecant of x, then I've got plus cosecant of x times cosecant of x, which is cosecant of x squared. Then I've got this minus, then I've got cot squared x. Well, that looks like a big hot mess. Let's see what we can do there. Have we got any? Look. Really helps if you have memorized things. Can you see what this is? That's coming from the Pythagorean identity, the one I call I cut cheesecake. You know that 1 plus cotangent squared x equals cosecant squared x. You've got to memorize that. But what we've actually got in our equation that we're working with, we haven't just got cosecant of x, cosecant squared of x, we've got cosecant squared of x minus cotangent squared of x. So what I have to do is I have to subtract that from that side, which is right there. Yeah. what's left on the left, what's left on the left? 1. So when I'm seeing this here, all of that is equal to, so it can simply be replaced by 1. Oh gosh, I can see this if you calculate this one. I've got cosecant of x plus cosecant squared. Oh no, plus 1. Divide. Don't multiply that together, just leave it. Can you see why? Okay. We have got this factor in the numerator is exactly the same as that. That could have been rewritten as 1 plus cosecant of x. So this factor and this factor are identical, and we've got division. Not addition or subtraction. We've got multiplication and division. You can cancel out. So we've got 1 over the cotangent of x, which is the same thing as the tangent of x. Have I finished, or did it say I have to write it in terms? Oh no, it just said simplify. Sometimes they tell you you've got to leave your answer in terms of sine and cosine. Okay. That was just my thinking on the previous question. Factor. Okay, right. You see what we've got here? This 9, think of it as 3 squared. So we've got sine squared x minus 3 squared. We've got difference of squares, which can be factored for your a plus your b times your a minus your b. That's your numerator. Divided by. So what do we have here? That's a factor in the denominator. It's just been multiplied by 1. Factors cancel. So we're simply left with sine of x minus 3. And I've got this very silly meme that's reminding me that when can you cancel? Okay. You cannot cancel this x squared with this x squared because that's not a factor, that's a term. If you're adding things, you can't cancel out a little bit in the numerator and a little bit in the denominator. You would have been able to cancel them if this had multiplication here. If that was multiplication, then that would be valid. But it wasn't multiplication, it was addition. I will write rude things on your tests and quizzes because every single time you cancel out a term instead of a factor, this cute little kitten dies. Okay. Right, let's keep on going then. One more. Look at what we've got here. You see? I'm thinking that a minus b times a plus b. I've got difference of squares. Remember, that would equal a squared minus b squared. That's what I'm seeing in my head. So the initial 1 minus cos x times 1 plus cos x could be rewritten as 1 squared, which is 1, minus cos squared x. And lo and behold, what would that equal? Now I'm thinking in my head, I know this identity. Sine squared x plus cos squared x equals 1. You have to memorize them. So what would 1 minus cos squared x be? Subtract cos squared x from both sides. That cancels that. 1 minus cos squared x could be rewritten as sine squared x. You could have done that if you don't like doing these little thought bubbles off the side, like I'm doing this thinking in my head. A different way you could have actually done that question is you could get this 1 and say, oh, I know that sine squared x plus cos squared x equals 1. So where I see that 1 here in its place, I can write sine squared x plus cos squared x. Then we've got the minus cos squared x. And then hopefully you can see now that I've got a zero pair. I'm adding cos squared x and subtracting cos squared x, so they cancel. You just left the sine squared x. That's probably a better way of doing it than thought bubbles off the side. I see too much of it in my head as I'm going along. Okay, pause your video, have a go at this again. Can you see this is difference of squares here? We're going to factor this. So we've got sine theta plus 5 times sine theta minus 5. That was difference of squares. And in the bottom here, I've got I'm going to factor it. With reverse FOIL, what are my only obvious factors of sine squared theta? Sine theta and sine theta. Adding means that what goes here and what goes here must be the same. And as I've got a negative there, I'm going to be subtracting in both of them. What are your obvious factors of 25? Well, 5 and 5. Does that give me this sine squared theta minus 5 sine theta minus another 5 sine theta does give me minus 10 sine theta, and the last is minus 5 times minus 5, which does give me plus 25. So I have factored it correctly. Check it in your head first. And because these lines were equal, we should really be writing the equals at the beginning of the line. Clear all that rubbish off. I wrote all of that. So what can we do now? Okay, we're multiplying. These are factors, they're not plus or minus, it's multiplying. So this factor is the same as this factor, and numerator and denominator cancel. So, oh, I've done it. They told us where we were going to aim for. These type of questions are easier than when it just says simplify. If it just says simplify, sometimes you don't know where to stop. But this was easier. It said convert from the first form, that's this one, to the second form, this one. These questions are sometimes written as show that this first identity equals. It said, sometimes they'll say prove the identity, or they'll say verify this is true. Many different ways these questions can be asked. Moving on, we're almost done. Aha, in fact, we are done. Let's just summarize quickly what are the techniques we've used today when we've been simplifying identities. Look through your work and see if you can come up with 1, 2, 3, 4, 5, 6 different ways we've actually simplified identities. Pause your video, come back and check. So, we were given 8 identities and you're replacing expressions with things they're equal to. The simplest technique is to just use your reciprocal and quotient identities that involve sine and cosine. So for instance, if you see tangent of theta, you replace it with sine of theta over cos of theta. If you see secant of theta, you replace it with 1 over cos of theta. That's what this technique means, that second one. If you've got 2 separate fractions, you can combine them over a common denominator. Look for difference of squares. Look for a plus b times a minus b, and you could replace that with a squared minus b squared. Or if you need to factor, you can go the other way. If you notice you've got this, you can turn it into that. Okay, so that was factoring. Identical factors in numerator and denominator can be cancelled. Only for factors, not for adding or subtracting. Not for terms. Terms cannot be cancelled. Only factors. When you've got multiplication or division. You can't do when you're adding or subtracting things, when you're multiplying or dividing by them. And we're done. There's your homework. Have fun.